Greetings, Terraformers. You may have never heard of Terraform's meta arguments, but you have probably used at least one of them. Today, Jason and I will give you an overview of all 5 of them. Meta arguments are perhaps oddly named, at least in the typical vernacular. I think when you really understand what they are, then perhaps it makes a lot more sense. But they are arguments, perhaps attributes in some ways if you think about it, that aren't necessarily part of the provider's syntax, but are part of the Terraform syntax, which help Terraform do its job, and some ways alter the way that it does its job. We'll start out here with depends on. And in depends on, we can see, as the example shown here, depends on gives us an opportunity to explicitly define the way that Terraform builds its graph for a resource. So just a quick aside, if we talk about some of the things that must exist for depends on, so depends on it has to be known for the evaluation. So when you do an apply step or a plan step, then you actually you're pre-evaluate first, and then you do evaluation, where you actually learn the output of a lot of the resources or attributes that you have. So sometimes you'll run a command and it will actually tell you, or actually when you look at it within the console, you'll see something that says this value is known after apply. So that means that it has to be evaluated first. Well, anything that goes into depends on has to be known prior to that evaluation step, just because of the order of operations. It's also sometimes, or I would say it's always considered a last resort. So depends on the way that you should do this is actually, if we look at this code on the screen, there is reference to variables outside of the code itself. So I have references to a local variable and I have reference to a module variable. And these are expression references as opposed to explicit references. Depends on would make an explicit reference. And expression references basically just tell the graph, tell Terraform, that it needs to execute or apply those resources before it applies this one, because there is an expression reference in it, and it has to be done before it gets to this. So this is an implicit expression reference, and this is the preferred way to do it. Now this particular code won't work that way because, and this is just very unique in this particular situation, but in this situation, the value, that is the expression on the right side of the equals greater than symbol, this value is not necessarily known until after the apply. It doesn't have to be known. The key, the key referenced here just to the left of the equal sign does have to be known. So as it evaluates this, it's not really going to look at the value until it gets into things, until it basically validates that this module can be run. Now I realize that's really confusing and perhaps a lot of extra information, but needless to say, in this case, the expression reference doesn't count because Terraform doesn't see this at the time of validating the module. So if I want this particular module done before, or if I want this particular module done after the subnet with NSG module is executed, then I have to put an explicit depends on reference. So enter the meta argument, and if I can type right, I can type depends on, and the depends on is a list type at this point. And basically all I need to add here, and this is just comma delimited because it is a list or a set, probably more specifically, I can just enter the variable or the resource that we are in fact depending upon. So in this case, I want to depend on module.subnet with NSG. So this just tells us explicitly to make sure that that module is executed before we attempt to execute this module. Otherwise it will not work. And in this case, it's largely because we have a dependency on the module values on the value side of a for loop within that. So complicated, but the depends on is not that complicated. It's an explicit way to define a dependency. We always want to encourage the implicit expression references, but sometimes you have to force this. Now, one of the other things that you can use depends on for is a comment notation. So I said that we should prefer an expression reference, and that is true. But in complicated code, I may want to put a depends on that basically just tells other code operators that there is an order to the execution of these modules. And it may not be obvious looking at the code, or it may not be quick looking at the code. So I can put a depends on here instead of putting a comment, and it now acts two ways, right? It gives me an explicit dependency reference, but it also basically creates a comment to somebody else, letting them know that there is an order, and maybe that order is only a preference and not an actual requirement. And so I might put it in here as such. So that's depends on. It's relatively simple, although I did put it within the context of a complicated situation. But we needed to see.
I've had to use this because, we rely on Terraform to create the chart, but sometimes, like, you figure out that when you're sending your code into the API, it just sends it all at the same time, and just like times out, or it's trying to create the key, like I say in the key vault case, it's trying to create access policy at the same time it's trying to create a key vault, which then it's also trying to create, whatever else you're trying to do at the same time. And so that it really helps break that up, because if you want to get to the point where you can just run your code as a one-time build and deploy instead of rerun it until the key vault's built, stuff like that. It depends on will help with that.
Yeah, I think that's fair, and that's kind of to what I was saying. If we have some order, even if it's just a preference, if we have a preference for order of operation, then this gives us a quick and easy way to define that, and also let others know, because it's not required. It will work, but it's desired in this case. The next one that we can go to is the provider, and the provider meta argument. Actually, it is I always thought of it more as a resource, but it is a provider type. But then there's also a provider meta argument that lives within most, if not all, of our resources. And the resource documentation may not tell you that it's there. Similarly to depends on, meta arguments oftentimes don't show up in registry documentation for resources. Instead, you just need to understand, and that's why they are meta, right? You need to understand that these arguments are available to you in most, if not all, resources. And as I say that, I want to just step back to depends on for just a second. Depends on added, and this is, I think this is pretty typical of all of these meta arguments. In version 13, that's when they added module support for most of the meta arguments. And notably that was used for count and for each. And I think those were some of the ones that people were really latched onto as being valuable, as having module support for those. But we'll get to those in just a minute. For now, let's look at provider. So in this case, I have the sort of the core code, the Terraform code with the required providers syntax on here. And then below that, I'm going to define the settings of, in this case, my Azure RM provider. And what I'm defining in this case is actually just a, in this case, it's actually a location, or a subscription difference. So I'm changing the subscription ID based upon, okay, so I'm looking at the provider for Azure RM. I'm going to define some settings for the specifics of that provider. And you'll notice that I've actually written this one twice. So I have one that is referred to as Azure RM, the second one's Azure RM, but I've also given it an alias. And alias is how it gets differentiated within Terraform, and also how the provider meta argument puts those to use. So in this case, the key difference between these is actually in the subscription ID, and they are being pulled in different ways and then being applied to separate subscriptions later down the road. And if we continue down, we'll see actually where I have the provider's map specified here, where I'm passing into the module the providers that I want to use for this particular module. And in this case, I want to use the alias version of the Azure RM provider. So I've specified that Azure RM equals azurerm.uscel. And so that is how I define aliases. So some notes about providers. One thing, providers have to be unquoted. They are literals. You can't use expressions. The provider alias, as pictured here on the screen, is azurerm.uscel. I didn't put quotes around that. I didn't derive it via an expression. I can't do either of those things, as helpful as it would be. Also, the first word in a provider is assumed to be the provider name. So if I didn't define some of my provider fields, my provider resource types in Terraform, or my required providers, just by using the name Azure RM, then it's going to assume that I mean the Azure RM provider, and it's going to go and download that when I do an init statement. So that's how the defaults work. If that is not the case, or if you changed it for some reason, then you will need to, of course, define those things within the provider syntax that's given in these other areas, both the Terraform and provider blocks. But the provider meta argument itself is pretty simple. I've put it into a module. As I said, this is available in v.13, which was notable. But it's also available for other resources. So if you have a resource group, or in the case of AWS, if you have VPCs and you want to create a new VPC in a different account, then you would use an alias and therefore a separate provider in order for you to do that.
I think I've used it to define like production versus, dev or something like that before.
Yeah, that's a perfectly good reason for it.
Though.
Yeah, because you want to switch settings completely, right, by switching to another provider. So production, non-production, very good way to do that, actually. The next one is going to be count. And count is one that I think a lot of people get familiar with early on. So maybe you didn't know that these were meta arguments, but you've actually used count before without realizing it. So count is one of those things that exists, again, for resources and, of course, now modules as of v.13. But it isn't something that's defined or documented by the providers themselves. This is a meta argument, and so it is therefore a Terraform argument provided with all these different types of resources. So this one, very simply, I'm creating a Linux virtual machine, and I am applying a count to it. And in this case, var.qty could be it could be 1, it could be 10, it could be 100. It doesn't matter. It's then going to iterate and create that many instances of that Linux virtual machine, and it will do so defined exactly as you have done in the code that you provided. So counts are really good for things that are actually duplicates of each other. They're all the same. There aren't a lot of differences that you can't derive by the count index itself. And you see here within this code, I've actually referenced count.index. So that is the flexible, or the variable that I have available to me within that execution. So if I need something to be different, then that's where I derive that from. That said, each instance is individual, and it's modified as an instance or an individual, not a group. So if I made changes inside of the portal to instance number 3 of a quantity 4, then when I go and reapply this, it's only going to fix instance number 3, because that's the one that is different now because of the way it's stored in state. It doesn't go back and reapply the group as a whole. And that's important to know, because another way of thinking of that is if I deleted number 3, then it's going to have to go and recreate number 3. It's not going to recreate all of them. The count.index that I have highlighted here that you can see, it's important to know that that is 0 based. So you have to anticipate that. And if you need it to be 1, then you would need to increment it by doing count.index plus 1, for instance. Or format, anything that you would like to apply to that to make changes to it. This, similar to depends on, I always want to say depends upon, similarly to depends on, the count has to be known before apply. So whatever var.qty is, it has to be something that's already known at the time of planning this particular resource. It can't be, for instance, the number of NICs that's created on a VM in this collection of virtual machines, right? That's too there. It'll be a cycle error. That's too convoluted. You can't pull something from the future to infer what this is going to look like in the present. I think that probably makes sense. So what else do we need to know about it? So this is a good one. It used to be that count was a way before we had for each, or before we had for each support within everything, within modules, within certain resources. We might use count to actually infer sort of a for each type syntax. And so you might actually take like a map that has a length to it, and you might pull a length on that, thereby giving you a number. So how many objects are inside this map? There are 3. Okay, then my count equals the length of that map. That was kind of a popular way to do things, so that then you could also use values from within that map or within a list inside of your code. The problem with that is that it's very fragile. So if that list changes that we're deriving length from, then again, these are instance based. So if I take out the middle item, so again, my length is 4 now, and I change my source list so that it is now, I take out the third one, then my length changes, and it's actually going to modify the third instance instead of skipping it and maintaining the fourth instance. Let me actually draw that out. So if I had a local here, and I'm going to say that my quantity will actually be derived from a list, and this is going to be just a list of numbers because that's how I wanted to name my machines, for instance. Having difficulty typing today. All right, so I have a local variable, local.quantity here, and each value within this list, 1, 2, 3, and 4, is actually going to come up to a total of 4 items. But unlike integers, then they are not 0 based, right? These are just strings. So if I were to, in another place, if I wanted to say my length of list equals, I can do the length function on local.quantity. Okay, and that's going to be 4 because there are in fact 4 items within that. So if I wanted to change this quantity to local.length of list, then now my count equals 4, and this would execute just as it did before, and I would still be able to use my count index as before. However, if I then changed this one to 5 for whatever reason, it's just the third item in the list is now named 5. This is still 4. It didn't change the length of things, but I have changed one of my items. So that's one way in which this is going to not behave the way you expect it to. The other way is if I now delete number 3 and I just have 1, 2, and 4, my length is now 3. And so what's going to happen is it's going to delete the 4th machine, but in this case, it's actually the 3rd machine the number 3 that I removed from the list. So it doesn't pay any relevance to the significance of the list items versus the count of those items. So that's where it becomes very fragile. And so typically we want to use our counts just as simple numbers, even if they are derived via expressions. And then everything will behave the way that you expect it to. Now, there is one other use case, and I'll just refer actually back to some of our previous code. So in this case, I have a count in that depends on example that we talked about before. This is local.create_NAT_gateway. So I'm actually using this as a Boolean. And while count can be 1, 10, or 100, it can also be 0. So if I think of it as a Boolean of 0 or 1, and Jason, I believe you've done this yourself in a number of cases, then if I set it to 0, then it will not create this resource. If I set it to 1, then it will create the resource. Now, what I have to remember that is if I'm going to refer to this instance now, module NAT gateway, that it's always going to be instance 0, because by setting an account, by setting count, even though there's only one of them, it's still now a list of items, and it will just be one item. So our index will always be 0 on that one.
I think I've seen that length issue before. It's been a long time. But
Yeah,
I think I broke stuff with that.
A lot of people don't use it this way anymore, but we had to be creative before all the functions that exist today and all the applicability of those functions.
It makes sense, but I think I might have done that once, like deleted
Got burned by it,
and then watch it just destroy the next 7 things.
Right, exactly. Yeah, it can be very tricky. And so for that reason, I think, for each exists now for modules, for resources. It's a fantastic option to have where we need values rather than just simple numbers. Now, something of interest and note here is that the goal of for each is very similar to that of count in that we're actually deriving a count. So when I do a for each, the count that comes from that is the keys. So the keys become the count, and now I'm going to iterate that many times. But I also have values, which give me something more that I can exercise within my code, as well as having the key names if those are important to us. So in this example I have now on the screen, we have a local defined, which is just a sort of a multi-step or a nested map. So I have a subnets map type, and one of those subnets is going to be the admin subnet defined. And then within that are all of the name value pairs that go into defining what an admin subnet looks like. If I come down into the module code for this, then I'm using for each, and I'm referring to local.subnets, which is this subnet defined up top. Now, I don't know how many subnets are defined. It could, as in this case, be 1, or it could be 10, or it could be 0 again. And just as I said, the count derived from the number of keys within local.subnets is now being used for the module. So for each, you can think of it as a count equals 0 or more. But then the extra value that I get from that is that I now have special words. I have each, and so then I have each.key and each.value. You can further subdivide those because each.value, so let's just walk through it, each key and each value. If I look at the keys of local subnets, it's going to map to this item. And then if I look at the values, it's going to map to this item. So these will be each of the values. So each key is going to be, let's just say admin, and then each value is going to be each one of these. But I could go further and say each value dot type, right? I could say each value dot cluster type listed on here. And I could add that to this just like this. And that is a valid expression within this module. So I have a lot more power to grab values, grab keys, iterate through things. I can even do for loops. Things can get really insidious, frankly, if I start adding for loops inside of my for each to structure a larger map that has multiple maps being pulled into it, filtering, conditional filters, all of these types of things. So there's just a whole lot more power given to us with the for each meta argument. But ultimately, we get the same artifact. I get a number of instances of this module, in this case, equal to the number of keys that I derive from my map that I'm creating. And let's see.
I think the biggest thing, like, that I've seen questions on is once you've used, so like for like the subnet with NSG, and you're going to use like another, say another resource referencing the same kind of like thing, you can use like, as long as you're using the same for each statement, you can reference the same array, right? So like you can say, as long as it says local subnets, you can do like each dot key when you're pulling in the values from a different module. Does that make sense? I've seen people ask questions like, well, how do I access it? I'm like, well, just use the same for each, and it's the same array.
Yeah, there's chaining. So I think for eaches are great for chaining where there is, like you're saying, a one-to-one link. So I have used this. So for instance, in the case of a virtual machine, you create a in Azure at least, and this may actually be true in GCP too. But at any rate, the virtual machine, I'm going to create the virtual machine itself. I'm going to create a network adapter. I'm going to create a storage account, and then all of these, and then I'm going to create a like a VNet association, a network association. So there's multiple things that happen for each VM. So if I'm creating 10 VMs, I need to do all of those things multiple times. Now, I could call a module, as the case is here, and it would just do each of those things multiple times. But I could also chain. So I could say that I'm going to create 6 VMs, right? And I think that's perhaps more like the count example. Yeah, so I'm going to create 10 VMs in this case. My next resource could be I forget the exact names of these. Azure AM, let's just say it's network association. I don't remember exactly. So within this one, I might actually chain it. So the chaining is going to look like this. I'm going to for each, and then I'm going to define the Azure M resource from above. So in this case, I've created a dependency, which is the one-to-one chaining that you're referring to. So I'm going to create a network association, but I'm only going to do it for every instance of the Azure RM Linux virtual machine up there. So this is a really great way for me not to have to use a lot of logic to figure this out, but to just maintain this chaining. And then I get the added value of grabbing things like maybe the name or the location from that I can use elsewhere. So some rules about for each. For each can actually accept maps or sets of strings. They do have to be strings. And just I guess a side note here, I realized this as I was saying it, sets versus lists, I think that probably is confusing at times. They are represented the same way within Terraform, so syntactically they look identical. But set values are unique, and that's why it's actually important that for each uses sets, because if you encounter a duplicate value, then it wouldn't know what to do with that, right? It wouldn't be able to reconcile that. It would either skip over it, or it would overwrite what was just created a moment ago. I'm not sure. I mean, it doesn't support it, so it won't work. I think it will just
error too.
It will just error, but I'm just thinking, what would you want Terraform to do in that case?
Yeah.
Yeah, sets are unique. So therefore, if you do a for each on a list type, then you actually have to call the toSet function to make it a set, and it gets rid of duplicates. It also gets rid of order. So sets are unordered. Though when I say that, it's kind of interesting because most things I've found will lexicographically sort sets. So for each is no exception in this case. If you do a toSet of some alphabet or some random list of items that was generated, when you call toSet and when for each encounters it, it will lexicographically sort those items. So it'll be alphabetical in the end. But it does change the order that they were in, possibly, right? It changes that order. It's arbitrary from the set type. So that's maps and or that's lists and sets, but then obviously a lot of people are using maps because you get the value of key and value. If you are using a set, then keys and values are the same thing. You still have each value and each dot key, but they're the same, and I usually just use each dot key in that case. Again, like counts, because this functions the same in count in many ways. Each instance is individual, so you're modifying an instance, not a group, no matter what kind of change you're making. If you make changes to your target item, then it will correct just the target item, not the entire group. Similar to a lot of the other meta arguments, the keys must be known. And so I'm going to go back to the complicated thing I started with. Maybe I should have put that later. So back here, I actually have a, this is not a for each, but it works exactly the same. But I have a for loop attached to this particular map. And in this case, it's successful because, again, my key is known. So my key comes out of just a simple local variable, and it's something that doesn't require anything to be applied for us to know the value of it. But my values are not known. And so just, I guess, and I haven't ever seen like a really good comprehensive demonstration of the processing order that Terraform takes. But for whatever reason, Terraform will ignore the fact that we don't know the value in this case, or it may not know the value, but it'll pass validation because it knows the keys. It'll step into it, and then it will realize, because in this case I put a depends on, which explicitly requires that module was run before, it realizes then that I do have the values that it's actually asking for. Mm-hmm. So that's kind of why this hack was required in this case. So keys must be known, chaining where there's a one-to-one link. The way that you refer to, so similarly when we talked about the Boolean count, right, a 0 or a 1. In the instance of the count, my resource is always referred to by its first index of 0, because it does create an index, and an index of 1 is still 1, right? So similarly, because it works very similarly again to the way count works, for each has the same requirement. It's going to be, it won't be referred to by the index though. In this case, it'll be referred to by the key. So so for each instance of this that I'm creating with local.subnets, it's going to take this key that's passed into it, into the for each, and it's going to append that to the subnet. So if I were to output this, then I would put this here, and I would just call the value in this case module.subnet nsg, and I would have to refer to the key name, which I can do this way, or more frequently I think you see it actually done this way. So I'm referring to the key name, and that's how I would get to that particular instance. And so for each instance, each key of the local subnets, that's how I would talk to it. And then I could go on from there and get that particular NSG name from that admin instance. So that's just kind of how I would refer to it. Well, that's fairly visible. And one last thing, you cannot use for each and count together. So I can't pull one of these which there have been a number of times when I wanted to, because it would simplify a lot of things. I need a nice iteratable index within my for each statement, but you have to get a little bit more creative and use things like length and range and things like that to derive numbers at that point. So that is, so that one's also, I think I mentioned this already, it's available in modules added in v.13. And that takes us to our final meta argument, which is the lifecycle. So lifecycle meta arguments is actually a little bit richer than I first thought as well. I use these, but I use them in a relatively small way. But there's actually a lot more that's been recently added to them that I didn't know about. So I think this is important to touch on. So life cycles have multiple, they're not like sub meta arguments, but that's kind of the way that I think of them. So life cycle has all of these subtypes. And I have one shown in this code called ignore changes, and it's just a list. It's probably a set, but again, syntactically they look the same. So I have ignore changes, but there's also create before. Let's see if it'll create before destroy. There is let's see. I have the ignore, there is prevent, destroy, which is interesting. And then there is also replace triggered, and it's probably not getting these because I didn't finish that one off. Replace triggered by, and then that would be a thing. Then there's create before destroy, and this would be a Boolean. And then there's a couple of new ones which we'll touch on in just a minute. But these are precondition and postcondition. So these are the subtypes of life cycles, and we'll go through the code a little bit just so that you understand the one that I'm using here, and then I'll touch on some of these other ones at the end. So in this case, I have a local that I've created, and I've created like this tag override, and this could be coming from anywhere. I just created it in the local in this case, and I'm defining a timestamp for the value start date. And timestamp obviously as a function is something that executes every time Terraform runs, so it's going to change for every time that you run it. And then I also have, and this is going to get merged, but I have a tag statement here where I'm merging multiple values. So one of those is I merge in subscription tags, and then I merge in any tags that the user might have defined. And then finally, I add local.tag override, which is the timestamp that in this case is the only thing that's being added. So then if we look at how that's used, I have just simply tags equals local.tags. So that's going to bring down the merged, the collapsed view of what tags are. But in the lifecycle meta argument, I now have defined ignore changes, and I've specified tags start date. And so you can kind of see how the syntax works here. It's tags and then the key value here. And if we look back, it's exactly, there's nothing special about that, right? Tag override is it's true. Tag override is a map. Tags is also a map. And so I'm just getting the key value from tags, and I'm ignoring any changes to that. So what that does is it means that if there's nothing defined for start date in this case, then it's going to apply start date using the current timestamp to apply that. On subsequent runs, though, we're going to see a difference between what Terraform is implying and what the resource has applied already. And that could go either way, right? Somebody could modify the start date on the target resource, which is not necessarily good. And our tag definition of start date may still be like a current date. In either of those cases, though, the reconciliation is going to be that we do nothing, because I'm ignoring any changes between my intention and my target. So any of that reconciliation just gets dropped at that point. Super helpful for a start date because I don't want it to change every time I apply. I want it to apply the first time and then never get applied again, so it should remain consistent. So that's kind of how the example works. Now, talking about some of these other ones briefly, I haven't used a lot of these. In fact, I haven't used any of these. So I'm going to talk about prevent destroy because this one's kind of interesting to me. Prevent destroy, I haven't used this because Azure has something called a
Resource locks.
Yeah, management lock. So Azure has management locks, and I always use management locks to do this very thing. So I create management locks for resources, and more often than not, resource groups, which can do a variety of things, right? It can prevent the destruction. It can even prevent the editing of those things. And so that effectively sets it to read only or no write, and just protects it at that point. But it's interesting to me to note that there's a prevent destroy right inside of Terraform. It may not be quite as capable as the Azure management lock, but in a provider where that doesn't exist, this would be fantastic, right? This would give me a way to protect something that the provider has no way of protecting. Now, it doesn't protect anything inside of the target provider. That, you know, if I go into if I use prevent destroy, if I go into Azure or AWS or GCP, I can still delete those resources, but I can't do it from within Terraform until I remove this value or change it to false. So I think that's pretty interesting and actually probably helpful for a lot of people that aren't using Azure, for instance. There's also some edge cases here. We've got create before destroy and replace triggered by. So create before destroy would be, I actually am struggling. I think it would be, I'm struggling to think off the cuff of something where I would use create before destroy. But I'm sure that there are cases where, because of the graph, because of the way things are structured, I need to create resources before they're destroyed. If I imagine, if I imagine an incomplete group of items, if I go to destroy that item, I'm probably going to error out a bunch because those items don't exist yet. Whereas if I have create before destroy set to true, then that means it's going to finish the job filling out all those items. Say, for instance, these, like the account of Linux VMs. I need 10 of those VMs for destroy to actually destroy 10 VMs, if that makes sense. And I may see some errors along the way if I just tell it to destroy out of hand. That's actually not true. It'll destroy those just fine. But there may be some situations where it will flounder because all of the things don't exist that it's intending to destroy. And that may be more of a state issue than anything else. So in this case, I can alter that behavior to ensure that it finishes the previous job before moving on to this one. And then replace triggered by would be a case where I want to alter what modifies a recreation of this particular item. So sometimes you have a dependency between things that is implicit rather than explicit. And what I mean by that is that, well, here's a good example. Let's say that I have created a resource group that has all kinds of tags associated with it, kind of like what we're doing here. And I'm using those tags as my my values for the tags that wind up here. Well, I don't know if that's actually going to work out in this case, but conceptually the idea is that if I alter those tags, they may not change the tags within this resource. They actually would, but let's just say I know that there are situations where that's the case. What I can do here is I can say replace triggered by. So in this case, well, here's another good example. Maybe one of my tags is actually the name of another resource group. Well, if I delete that resource group, then maybe I need to recreate this whole object because maybe it's invalid now, right? And I don't want it to exist. So in this case, I'm setting a trigger event up to the resource group, to whatever that remote resource group is. And I'm saying that if anything happens to that, then recreate this as well, because there is a dependency between them that isn't actually within the graph or isn't obvious,
Mm.
but I want to make it important and explicit.
Yeah, that makes sense. Like if it's doing some sort of like any sort of link to it and that resource group gets replaced or something like that, then you might want to rebuild your virtual.
Yeah. There's always going to be some exception for why you need to do that, and this actually gives you the capability of doing it. And again, these aren't documented within the registry, within the provider documentation. These are meta arguments, and so these are Terraform arguments that you can apply to almost anything, and I think probably anything at this point. Although actually, so I've been saying that v.13 brought support to modules all along the way and resources. So for lifecycle, it is actually not yet a part of modules, or perhaps it's that you can't use life cycles within modules at all. So you could use them within the modules, within the target child configuration that's defined, but you can't use it within the module definition itself. Okay, and so then just talking a moment about precondition, postcondition. So these are something that are really new. As of version 1.2 and up, these are things that have been added to life cycles. These only exist within the same module, so they can't dip into child modules. It has to be within the same context, which also means that they are what I would call self-aware. And what I mean by that is that there's a special value called self, and you see this within dynamic providers, for instance. But it's a special keyword, so I can say self.name, and it would refer to this resource's name, because I can't refer to Azure IAM Storage Account.this yet. So instead, I refer to self.name, and it knows the name that's being used within the context. So precondition and postcondition are self-aware. So the idea of precondition and postcondition are that you can set up some validation around your resources. So you can create an expression that that must map to true in order for it to move ahead. Same with postcondition. You must, after the result of this is created, this particular expression must result in true. So if I wanted to say if 0 equals 1, then obviously that's false, and it's not going to move ahead with this particular resource creation. And actually, anytime you create a false statement like that, if I say 0 equals 1, then it's actually going to print that as an error. And so it'll give you a reason why it failed, and in this case it'll be because 0 does not equal 1. But if I said that 0 equals 0, then it would move ahead with that precondition. And then the postcondition, same way, I could say 0 equals 1, still not true, so it's actually going to abort that creation, roll it back. But if by creating that resource suddenly 0 does equal 1, then it will allow it and continue forward with the next one, or just exiting out successfully. So these are kind of interesting. We've not really had a lot of validation in Terraform before, but precondition and postcondition, it gives us some ability to do that. So I'm looking forward to some opportunities that I can use those, but haven't had to use it yet. It's very new as of yet. So that is the meta arguments, and I hope that helps out a lot. As always, thank you for watching. Like and subscribe to stay up to date with future releases, and join us on Discord to be a part of our Terraform community. Thank you.
Thank you.